Alright, so what I have here is I have a scatter plot. And what I drew in is I drew in the mean point. Okay? And that mean point is right here, right in the middle. So I'm going to add a point right up above the mean point. Now, actually, let me throw that point away for a second. First of all, to start with, our correlation is 0.54. That's right here. Okay. Now, when I add my point that's right up above the mean point, it did influence the correlation. Okay. And the reason it did is because while the z-score of the y is 0 there, because it's right on the x is 0, the z-score of the y would be pretty high. So what happens is that makes our correlation, and what winds up making our correlation decrease, because you would have 0 times some high number, and that would then throw off our calculation. Okay. Alright, so when a point is high above the mean point, either high above or high below, if I was to bring it down here, okay, we call that a low leverage point. And the reason is that leverage is created in a horizontal direction. Okay. So let me take our point and move him right there. Now we have we went from a correlation of 0.54 to a correlation of 0.8813. So this guy is far away from the mean point in a horizontal direction. Okay. So what we call that is we call that a high leverage point. Now notice this point didn't really change the line. Okay, it didn't influence the slope of the line, it didn't change the equation of the line in any significant way. However, it did change the correlation significantly. Matter of fact, the correlation increased by about 0.3, or a little bit more than that. Okay, so that's a high leverage point. Now let me take this point and move them down. Now, that point did two things. It changed the line. The slope was originally positive and it's now negative. Okay, and it decreased the correlation to where now the correlation is negative. So that did two things. Okay. So what we call this is, yes, this is a high leverage point because it's far away from the mean point in a horizontal direction. But we also say that this is an influential point. And an influential point is any point that changes the line. Okay, so you have three kinds of outliers right now. Let me take one of those points and throw them out. You have low leverage. Okay. Right up above or below the mean point, this would still be kind of low leverage because it's in the domain of the clusters. Okay, you have high leverage, and then you could have influential. I could have influential the other way. If I put the point way up there like that. Okay, that's also a point that significantly changed the equation of the line. Okay, so did you see what the high leverage point did to the correlation? It increased it, right? It brought it closer to 1. And that's pretty easy to understand. Now let's get into the harder case. Okay, I'm going to erase everything here. And let's say that, hold on. Let's say that we have this guy. And I put in our mean point, and I show our least squares regression line. So now we have a negative sloping line. So I add a point right there. What did that point do? Well, that point brought the line down. Okay. What else did it do? It affected the correlation. Okay, so if I just take this point and throw it out, the original correlation is negative 0.86. If I add a point right there, the correlation goes down to negative 0.4. So it made the correlation weaker. However, you had to be careful here. If my original correlation was negative 0.8 and I went to negative 0.4, what did the correlation do? Well, the correlation actually increased. Because I have a negative relationship, this point made the correlation closer to 0. So you have to get this in your mind that just because the correlation increases does not always mean it's going to mean that the correlation got stronger. That's only true for a positive relationship. In a negative relationship, it works the other way. Okay? Now let's take our high leverage point. Stick him right there. Our original correlation was negative 0.86. Our new correlation is negative 0.96. Okay? Well, what did it do? Well, it made the correlation closer to negative 1, and negative 1 means that we have a fairly strong linear relationship in a negative direction. But in effect, what did it do to the correlation? Well, if it went from negative 0.86 to negative 0.96, the correlation actually decreased. It made it stronger, but the correlation decreased. And that happens because it brought it closer to negative 1. Okay? And then last one we have, so that's our high leverage point. We went through the low leverage point, and then we would do an influential point. Okay? So if I just did that guy right there, that's influential. The original line went like this, and the new line is now changed. So this is high leverage and influential. Okay, so that's something to keep in mind as your key as we discuss outliers in this chapter. The other issue I want to talk about is the danger of extrapolating. Okay, so I think we talked about this last chapter, but let's say we have a stock market over 5 years. All right, so what generally will happen is the stock market moves in kind of a staircase type pattern. It goes into these bull trends, and then it goes into these bear trends, and that's how the market will move. So overall, you're saying, well, it's in an uptrend. Well, okay, the stock market's in an uptrend, but if we look at the first trend, what if we were right here? What if we said, oh, the market's in an uptrend, so we're just going to invest more money? You would have lost money over the next 3 years. Okay? And then we say, we're not going to invest here because the market keeps going down. Well, next thing you know, the market started an uptrend. Then it went into a really steep pullback. Okay? Another downtrend and then another uptrend. So the whole point of this is be careful about forecasting linear trends into the future. There's no guarantee that they're going to continue. Alright, so let's talk about Chapter 9. We talked about some of this stuff already. When using a model to predict the value of the response variable, two types of predictions can be made. And those are interpolation or extrapolation. Making predictions within the given domain of x values is called interpolation. Making them outside of the given domain is called extrapolation. Only interpolation is reliable. Talked about can't count on trends continuing. Extrapolation is unreliable because patterns can change abruptly. So even if a model is linear model is appropriate, remember that association does not imply causation. One of the best examples of that is, let's say that you were to plot two things. You were to plot ice cream sales and then ice sales. Okay, and let's say that that was pretty strong. When ice cream sales went up, ice sales went up. Okay. Well, what does that mean? Does that mean that ice cream sales is causing ice sales? Well, no. What we have here is what we call a lurking variable, or other variables that are contributing to this association. And what's the lurking variable? Well, the lurking variable is the weather. When it gets hot out, ice cream sales increase. Okay? When it gets cooler out, ice cream sales decrease. Well, when it gets hotter out, ice sales increase. When it gets cooler out, ice sales decrease. Okay, so even if you have a linear relationship and you have this, and r equals 1 and r squared equals 100%, you cannot assume that this variable caused that variable to happen. Okay? You cannot apply causation. All you can say here is there's a very strong association. That's all you can say. So, in this case, there may be other variables that account for the association. That's why we cannot. We have this. You got to watch when we say that one variable causes another. We can't say that. We can only say there's a very strong association between the two variables. Okay. If we're plotting summary values, okay, instead of the mean, the association may appear stronger than it is. So if I was to plot the if I was to go to 4 high schools, let's say Brian McMahon, Norwalk High, West Hill, and Stanford High School, and I was to get the height and weight of let's say 50 students in each high school. Let's say there were 50 let's say that they were 50 upperclassmen, okay, females, okay. I would get a scatter plot. You know, I would have 200 points on there. Well, if I use the average height and weight for the 4 high schools, I would only have 4 points on my graph. So I might have something that looks like that. And I say, holy cow, that's a lot stronger than that. Well, that's the problem with using summary statistics. Okay, when you use summary statistics, all that variation goes away, and the model looks like it's really strong. Well, in effect, it's not. Okay, so don't use summary values. Alright, so outliers and leverage and influential points. I already went through a lot of this. So when examining a scatter plot, it's unusual. So point is unusual if it stands away from others. This is called an outlier. I can have an outlier there, I can have an outlier there, I can have an outlier here. That's low leverage, high leverage, high leverage. This would be influential, and this would be influential. Okay, so those are your different types of outliers. Point is unusual if its x value is far from the mean of all the x value. This is called a high leverage point. Okay, so if I had the mean point, let's say it was there and there, there's your high leverage point. Okay. A point is unusual if when omitted it significantly changes the linear model. This is called an influential point. So if I was to do this, everyone would see a line of best fit that would go something like that. If I put that point in there, then the new line of best fit would probably go something like this, and that's an influential point. That's also a high leverage point. Another factor to consider: the effects of outliers, influential points, and high leverage points on the graph itself, and the strength of the pattern to begin with. Okay. So it'd be very easy for me to influence this line. All I got to do is put a point like right there, and that's going to be an influential point. However, for this one, it's going to be really strong. So if I was to put an influential point, if I had to put it up here like that, because that's a much stronger pattern than that one. Okay, a scatter plot is shown below with 6 points. Loaded our 3 graphs with a 7th point added. So we put these points into the calculator, and then we're going to change this. So let's see here. We're going to go to Stat Edit, and I'm just going to clear all this out. And let's see, this is 2, 2, and 2, 4, and 3, 4, and 3, 6, and 4, 6, and 4, 8. Okay. And if I was to graph those, it would look like that. And if I was to calculate the least squares regression line, it would look like that. So my R is 0.85 and my R squared is 0.73, and my slope is 2. So okay. So now we got to add the point 310. Okay, so if I add the point 310, then that's a low leverage point, right? Because that's going to be right up above the mean point. So if I add that point, and I calc my new linear regression equation, then what happened to my slope? Well, nothing. It's the same. The slope is still 2. My R is now 0.61, so it went from 0.85 to 0.61, so it decreased. And then my R squared also decreased. It went from 0.73 to 0.36. Right? Now we got to add the point 1020. So this, by the way, is called a low leverage point. This is called a high leverage point. I could see that that's going to be pretty much on the line, so that's not an influential point. So we're going to change, and we're going to add the point 1020. And my slope changed slightly, so it was the effect on B1 was minimal. My R squared, my R went 0.99 from 0.85, so it increased, and my R squared went from 0.73 to 0.97, so it also increased. So type of outlier that is, that's high leverage. Okay. And then this guy we're going to talk about, this is influential. So if your original line went like this, then your slope, what's the effect on the slope? It's going to decrease. Okay, the new slope is going to go like that. Effect on the correlation, I'll add it, but it's going to decrease. down to 0.06 and r squared is 0.004. So both of those decreased. Okay. So those are your three different types of outliers. Low leverage, minimal effect on the slope, will have a slight impact on correlation and r squared. Your high leverage point, minimal effect on the slope, but will strengthen the correlation and always increase r squared. And then the influential point, in this case, decrease the slope, decrease the correlation, and decrease r squared. Now we got to put these points in our calculator. So let's clear this out. So we got 220, 218, 318, 316, 416, and 414. And we're going to just take a look at those, and those go like that. So if we calculate that, our slope is -2, our correlation is -0.85, and r squared is 0.73. Okay, so now I add the point 1015. Well, the point 1015 is right below the mean point, so the effect on the slope, so we'll add that in. The effect on the slope should be minimal. And let's see. Let's see. Oh, add the 0.3. 3. Let's see, add the point, this is going to be the 0.35, I think. That's what that's supposed to be. It's supposed to be 3.5. We're going to add that. And let's see what happens when we count that. So we still got a y-intercept of a slope of -2. So the effect on the slope was none. Our r value went from -0.85 to -0.33. So what happened? Well, it increased. It got closer to 0. And then the effect on r squared went from 0.73 down to 0.11. So that decreased. And this is a low leverage point. And next we want to put in the point 10.2. So that is called a high leverage point, but not influential because it's right on the line. Okay? So the effect on the slope should be minimal. It is. Affected the slope slightly, but really not significantly. The effect on the correlation should bring the correlation closer to -1. And the new correlation is -0.99, and the original one was -0.85, so it decreased it. The effect on r squared was 0.73, and it's now 0.97, so it increased it. And the last one we got is this is a influential point. And we know that the original line went like this, and that's going to shift the line up. So I can tell you right now the slope is going to increase, but let's add it in. It's the point 1015. And yeah, our slope went from -2 to -0.4, so it increased it. Our r value went from -0.85 to -0.58, so it increased it. Made it closer to 0, and r squared went from 0.73 to 0.34, so that decreased. Okay, So those are your three different types of outliers in a negative situation. You've got to be careful when you're interpreting the correlation. Okay, when it makes it weaker, it actually increases it, and when it makes it like this case right here, but when it makes it weaker, as in these two cases, it actually increases the correlation because it brings a negative number closer to 0.